Good morning. Welcome back to Pre-Algebra with Miss Betsy. Today we're going to be talking about how we round decimal numbers, and we'll see that while it's very similar to rounding whole numbers, there's a key difference that we need to be aware of. I am using as my text Pre-Algebra for Christian Schools. It's the first edition, not directly compatible with the second edition, but the principles are still the same. I'll be on page 85 of the text as we start in just a moment. But let's pray and see what my lame joke for the day is. Father, I thank you that you love us. I thank you that you are bigger than anything that I can imagine. Lord, I ask that you would help me to communicate clearly today, that you would help my students to understand the material, and that we would be diligent to accomplish all that you have us to do today. And I thank you once again for your presence with us, and I pray in the name of Jesus, amen. So, our joke or riddle or whatever you wish to call it for today is, let's imagine that you're in a room and there is an oil burner, there's a kerosene stove, a kerosene lamp, an oil burner, there's a kerosene lamp, and there's a wood burning stove, and you've got the match, and you are trying to decide what in the world you want to light first so that you can get all of these appliances going. Oil burner, kerosene lamp, wood burning stove. What are you going to light first? Well, in order to light any of those, you first have to strike your match. So I would be interested to know how many of you got that one correct. Rounding decimal numbers is very, very similar to rounding whole numbers. But I've got a little review here going vertically instead of horizontally so that I can keep this on my board here with place value. Down here at the bottom I have 123.4567. or 123 and 4,567 ten-thousandths. And I begin up here at the top to tell you that first place value is hundreds, tens, units, or ones. Now we have our decimal point, which we pronounce as and. Tenths is the 4, hundredths, thousandths, and ten-thousandths. And when we're rounding, we always have to look at the place to which we are rounding. It's not going to do us any good to say, well, let's round this decimal number to the nearest thousandth, if you don't know that 6, the digit 6, is in the thousandths place. So if you're still unclear of tenths, hundredths, thousandths, ten-thousandths, and where they appear in relationship to the decimal point, then you need to go ahead and make sure that you've got that clear before you begin doing any work from this section. You can go back for a review in your text of section 3.1, or there's a plethora of videos and resources out there on the internet available to help you work with decimal value, with decimal place value. So let's go ahead and look at page 86. And we have one example, and it says we're going to take this number and we're going to round it to a variety of places. And we have 8.6075. 8.6075, and we're going to round it to 4 specific places. The nearest whole number, and the nearest tenth, then we are going to round it to the nearest hundredth and to the nearest thousand. Nearest hundredth, and it's DTH, and finally we are going to round this number to the nearest thousandth. How are we going to do this? Just exactly the same as the way in which we round a whole number, with one tiny little twist. Let's see if I can get over here. I'm still partially in the video, and I'm going to move back in and just sort of do this in a different order than I thought I would at first. First, I'm going to show you how we're going to round this to the nearest whole number. When you're rounding decimal numbers to the nearest whole number, it's always going to be to the units place. It's always going to be to the ones place. We look at the digit in the place to which we are rounding, and we have an 8 in that digit. An 8 in that decimal. Can't speak today. We have an 8 in that place. We look at the digit to the right of it. If that digit is a 5 or above, you're going to increase the 8 by 1 number. 6 is 5 or above, so this becomes 9. That's the end. We want to have the nearest whole number. A whole number does not have a decimal point in it. Nearest whole number is 9. Now we want to look the nearest tenth. Now we didn't say the nearest 10, we said the nearest tenth. Where's the nearest tenth? It's the space that is immediately following the decimal point. So our 6 is in the tenths place. We look to the digit to the right of this, which is 0. Because this digit is not 5 or above, in other words, it's 4 or below, the digit in the place to which we're rounding, which is the tenths, doesn't change. So we have 8 and 6 tenths. We're rounding to the nearest tenth, so the last digit that you are going to have in that number is going to be in the tenths place. We're not going to put a bunch of zeros on there. Now we want to round to the nearest hundredth. Which one of these places is the hundredths? Well, we have tenths, then hundredths. So our 0 is in the hundredths place. Same rule. Look to the digit to the right of it. It's greater than 5. So our 0 is going to increase 1. It's going to round up to 1. So 8.6075 to the nearest hundredth is 8 and 61 hundredths. Remember, when we read these numbers, we pronounce the place value of that final digit, 8 and 61 hundredths. So since we're rounding to the nearest hundredth, our last digit is going to be in the hundredths place. We're dropping any other zeros. Finally, if we're going to round this number to the nearest thousand, you need to know that 7 is the digit that's in the thousands place. You have to look one space over to the right, which is the 10,000th place. Because it's 5 or above, this digit is going to round up. So we have 8 and, let me see, 608 thousandths. 608 thousandths. We're not going to have anything in this in the 10,000ths place to the next of it. Because we are rounding to the thousandth place, our final digit has to be in the place that has the value of thousandths. So we have 8 and 608 thousandths, 8 and 61 hundredths, 8 and 6 tenths. Your homework is going to be self-correcting for you. If you make certain that you actually physically say 8 and 608 thousandths, or just say it in your head, because this will tell you that you have matching place values. Let's say, though, that rather than having rounded this, as I just illustrated for you, you thought, oh, I need to do this exactly the same way that I would round this number if it were a whole number. And that would be, okay, I've rounded this to 6, and then I have all of these other zeros here. That's rounded to the nearest tenth, isn't it? No. Read the number. This says 8 and 600 thousandths. This is where the difference is when you're rounding decimal numbers. You're going to drop any zeros that occur to the right of the place value to which you're rounding. If we tried to round 8.6075 as if it were a whole number, and we would have 9.1234 zeros, this would be, we want it to be rounded to the nearest whole number, but we put these zeros in because we thought we were supposed to. And this is read 9 and no 10 thousandths. 1, 2, 3, 4. What does it say to round to? It says round to the nearest whole number. It doesn't say round to the nearest 10,000th. So that one's wrong. You don't need those green zeros. Same thing here. We're going to round to the 100th place. We think we have to add zeros again. What do we have? Read it out loud. 8 and 6,100 10,000ths. Is that what it says to round to? No. So you don't need those zeros because we're only rounding to the 100th. 8 and 61 hundredths. Same thing, of course, you see exactly where I'm going. If we think we have to round to the 1000th place, and we know that the 7 is in the 1000th place, but we keep that 0 on there, this number here is actually pronounced 8 and 6,080 10,000ths. We're not rounding to 10,000ths. We want to round to the 1000th. So those zeros at the end, we say they're truncated. You don't show those zeros at the end because you have to pay attention to what place value you're being asked to round to. Now, is there ever a reason for a number like this that says 9 and no thousandths? These have to do with very specific, precise measurements that you would use sometimes in medical science or in engineering or in very precise drawing and drafting. So 9 and no 10,000ths is a very different number from 9, but it's not a difference that is meaningful to you right now. So you need to be very careful when you are rounding these decimal numbers that you don't put those extra zeros in, because when you do, you change the value of your number. So this difference right here is the tweak that you have to be very careful of when you are rounding decimal numbers. So, what are we going to do if we want to estimate sums and differences for decimal numbers? It's going to be very, very similar to estimating sums and differences for whole numbers. And I'm looking at your text on page 86, and this says, round each decimal to the specified place, compute the estimate using the rounded decimals, just the same way that you estimate using whole numbers. Example 2 says, estimate the value of the variable by rounding to the nearest tenth. A is equal to 13 and 96 hundredths plus 8 and 74 hundredths. What do our instructions say? They say round to the nearest tenth. Does it say add the numbers and then round that sum to the nearest tenth? No, it says round to the nearest tenth. Estimate the value of the variable by rounding to the nearest tenth. The 9 is in the tenths place here. Now this is going to be a little bit different. We're going to look at the digit that's in the tenths place. If we look to the right of that, because that digit is 5 or above, we're going to increase this by 1. But when that 9 becomes a 0, we have to carry a 1, don't we? So we have 14.0 plus, now before you even go there, I'm hearing you, through this internet, you're saying, Miss Betsy, you put a 0 there and you said not to put zeros. You just taught us that. This is a little bit different. What are we doing here? We're rounding to the nearest tenth. If I didn't have that 0, this would be 14, which is a whole number. It specifically says round to the nearest tenth. So you have to make sure that you have a digit in whichever place that you're rounding to. And sometimes there will be a 0, but it's only when you're rounding to that specific place. Because now, when we read this number, we have 14 and no tenths. So we've rounded it to the nearest tenth. You could also pronounce that 14 and 0 tenths. Now we're going to round 8.74 to the nearest tenth. The 7 is in the tenths place, and that rounds to 8.7 because the digit to the right of that is less than 5. Now we can add these, and now if you can't do this in your head, it's perfectly fine. Line up your decimal points, and your estimated sum is 22.7. Now some of you out there, and some of you moms or dads, if you're working with your kids, you're saying, I thought we were estimating. 22.7 is not an estimated number in my book. And that's because we're used to rounding up. Maybe the most frequent way that we round things is to the nearest dollar or to the nearest $5 or $10. So that's how our minds think of rounding as being meaningful. But this really is in the realm of small numbers. This is an estimate. We've got hundreds involved here, and we've rounded to tenths. So that's maybe a presumption or a presupposition that we have that rounding is always going to end with a 0 or something. Not true when you're working with decimal numbers. So now, sometimes they're going to ask you to round decimal numbers, but they may not specify a place value. Example 3, this says, if you're not instructed to round to a specific place, estimate by rounding each number to the largest place of the smallest number. Largest place of smallest number. This right here is going to be the key that will help you be able to solve these problems correctly. Now, our problem says estimate the value of the variable by rounding. N is equal to 117 and 3/10 plus 43 and 9/10. And we want to estimate the value of this variable by rounding each number to the largest place of the smallest number. Looking for my pen cap and I can't find it, so I'll use this right here. Black pen with a green cap. Largest place of the smallest number. Which one of these numbers is the smallest? 43 and 9/10 is the smallest number. And this right here, the 4, the 10s is the largest place of the smallest number. And maybe none of you had any difficulty at all understanding what they're talking about when they say the largest place of the smallest number. Sometimes our minds get twisted around when things are phrased like this. All they're saying is look for whichever number is the smallest one in the series of numbers that you're adding. Round both of the numbers consistently to that highest place right there. If your largest number is in the 10s, then you're going to round both of these numbers to the nearest 10. So we're going to have the value of n is approximately equal to, how do we round 117 and 3/10? We're going to round that to the nearest 10. So n is approximately equal to 120 plus 40. We're going to round each value to the nearest 10. And you say, oh, but you did it again. You put those zeros in there. Well, if I didn't have a zero, how are you supposed to know that's 120? If I don't have a zero, how do you know that that's supposed to be 40? You have to keep the zeros in that are to the left of your place value. I'm sorry, that are to the left of your decimal point, because you need those so that you know we're talking about 120. We're not talking about 12, we're not talking about 1,200,000. Zeros are necessary as placeholders when they occur to the left of the decimal point. So the approximate sum is going to be 160, rounded to the nearest 10th. Now, I am going to go ahead and track through all of the skill check on this. Because this section, especially when you come to where you're rounding, this can be something that you think is so simple and straightforward that you default to the rules for rounding whole numbers, which will cause you problems, and I don't want that to be the case. Example number 1 says 0.649. How do we read this number? It's 649 thousandths, and it says round each number to the nearest whole number, tenth, and hundredth. To the nearest whole number, it would be 1. To the nearest tenth, the 6 is in the tenths place, so it's going to be 7. It's going to be 6/10, isn't it? The 6 is in the tenths place. We look at the 4. We drop those zeros because when we round this to the 10th, we have to have the last word out of our mouth be 10th. So we have 6/10. Now, if we want to round this number to the nearest hundredth, the 4 is in the hundredths place. The digit to the right of that is 9, so this will round up to 65 hundredths. Would be how we round 0.649 to the nearest whole number is 1, to the nearest tenth is 6/10, to the nearest hundredth is 65 hundredths. Now let's go ahead and look at problem number 2 in the skill check, and that is 7 and 35. Is this 7 and 35 hundredths? No. This is 7 and 35 thousandths, because the 5 is in the thousandths place. We're going to have the same rule. We're going to round to the nearest whole number. Whole number would be 7. The digit to the right is 0, so it remains the same, 7. How do we round this to the nearest tenth? We're going to look at the 0 is in the tenths. The 3 is less than 5, so there's no change. So rounded to the nearest tenth, we do have 7.0. That 0 is necessary because if we don't have the 0 there, we're going to read the number 7, aren't we? But we're supposed to be rounding to the nearest tenth. 7 0/10. Then rounded to the nearest hundredth. The 3 is in the hundredths place. Because the digit to the right is a 5 or above, this rounds up, and we have 7 4/100ths. So these are two more examples, two more illustrations of rounding decimal numbers and how sometimes you need zeros, sometimes you don't. Now, we're going to estimate the value of the variable by rounding to the nearest whole number, and we have two examples. We have x is equal to 1.63 plus 3.26, and we have m is equal to 45.36 minus 27.68, and these are problems number 3 and 4 on our skill check. What do our instructions tell us to do? We're going to estimate by rounding to the nearest whole number. Which is the whole number here? Nearest whole number. 1.6 rounds to 2. 3.2 rounds to 3. The nearest whole number estimation for the value of this variable is 5. We say that x is approximately equal to 5. Now, we have numbers that are written out with hundreds. We want to round these also to the nearest whole number. And you know what I was going to do, guys? I was going to add these. It says to subtract. And you can put this in the real world by saying $45.36 minus $27.68. You can round this so you see about how much it's going to cost by rounding it to the nearest whole number. Nearest whole number is always going to be in the units place with decimal numbers. So the value of m is about 45. We're going to round to the nearest whole number. The digit to the right is less than 5. So that becomes 45 minus 27 68/100ths. The 7 is in the hundredths place. The 6, can you believe that I said hundreds? Let me back up, I'm not sure what I just said. We have 27 68/100ths that we are going to round to the nearest whole number. The 7 is the nearest whole number. We look at the 6 to the right of it and it rounds up. We now have 45 minus 28, so that m has an approximate value. Is that right? See what happens when you sometimes do your subtraction in your head? That's not right, is it? 13 and 28 doesn't equal 45. So sometimes even the teacher should do her subtraction out to the side, because then it's obvious that the approximate difference here, which is a solution to a subtraction problem, we have a value of 17. This is adding and subtracting when we round to the nearest hundred. Okay, now we're going to round to the nearest tenth. Okay, t is equal to 7.183 plus 2.638. We want to round this to the nearest tenth. So the value of the variable t is approximately equal to, how do we round this one to the nearest tenth? There's an 8 to the right, so this becomes 7 2/10. There's a 3 to the right of the 6, so we have plus 2 6/10. So the value of the variable t is going to be approximately 7 plus 2 is 9, and 8/10. And I know I've rounded that to the correct place. It asks me to round it to the nearest tenth. And when I read that number, my tongue stops at tenths. 9.8/10. A subtraction problem. This is number 6 in the skill check. Y is equal to 54 and 63 hundredths minus 33 and 82 hundredths. So now we want to round this to the nearest tenth also. What do we have for our tenths here? 6, 8. Okay. My glasses giving me a bit of trouble there, sorry. Going to round to the nearest tenth. Y is 54 and 6/10 because we have a 3 minus 33 and 8/10 because we have a 2 to the right of 8. Now, off to the side of your work, show your subtraction. 54.6 minus 33.8. And we have not 10.8, do we? But we should have 20 and 8/10 is going to be our difference when we round, when we estimate the value of the variable by first rounding to the nearest tenth. Do not add these two numbers together and then round it. That's not what they're asking you to do. They're saying round first and then add or subtract. I'm going to skip number 7 and 8 because we're just rounding to the nearest hundredth. Same exact type of operation that we've already been doing, beating a dead horse here. I do, however, want to do problem number 9 and problem number 10 in our skill check, and we're going to estimate the value of these variables by rounding. 329 and 7/10 plus 203 and 4/10. And then we have Z is equal to 236 and 4/10 minus 45 and 9/10. Now they didn't give us instructions here, round to the tenths, round to the hundredths, so we go back to our rules that we talked about earlier. When we're adding or subtracting decimal numbers, when we want to estimate first, we're going to estimate to the highest place value, or the largest place value of the smallest number. Well, the smallest number is 203. The highest place value of 203 is in the hundreds. So we're going to round both of these numbers to the nearest hundred. And we have 300 plus 200, so that the approximate sum is 500. I rounded both of these numbers to the nearest hundred. Now we have another math problem we're doing here. We want to estimate the difference. Again, they didn't tell us what place they want us to estimate to, so we are going to round to the largest place of the smallest number. 45 and 9/10, again, is our smallest number. The largest digit here is in the units tens place. So we're going to have to round both of these numbers to the nearest 10. What digit is in the tens place here? The 3. So we're going to round 236 and 4/10 to the nearest 10, and that's going to be 240. We have to keep one of the zeros. We don't keep that second one. We're using that 0 as a placeholder. This is rounded to the nearest 10. 45 rounded to the nearest 10 is 60, and the difference there, the approximate value here, is about 180. What did I do wrong? 60. Aha. Do you catch my mistake here? How in the world does 45 9/10 round to 60? In my head, I'm thinking the 5 goes to 6, but that's not the place that we rounded to. We're rounding to the nearest 10. We have a 4 in the tens. It does round up. This should have rounded to 50. And I would hope that all of you caught that and wondered what in the world I was doing. 240 minus 50, we have an approximate value for z of 190. And that's the end of this video. Send me a text if you need help, or I'll see you in class on Friday.